Now we're going to look at two molecules and figure out if they're going to be the same or not. And if they're not the same, then what are they? Are they enantiomers? Are they different? Kind of assign what they are. So here are the two molecules, okay, that we have. So in these two molecules, what do you have? Br, Cl, CH3, right, and hydrogen, and their orientations are given to you. So there are two ways of doing this kind of a problem. Number one is to make the models for both of them. Okay, so in both cases, the molecule is actually standing on its head. So for me, it's a little bit different because I'm just going to place them over here. So make the model, okay, first of all, and then compare. Okay, so this you can do if you have more time, right? So if you're practicing at home and you're looking at, making the models to see, then this is a good thing to do. In an exam time, you're a little bit more under time stress. Okay, so I'm going to tell you how to do that too. But let's work with models first. So here's your model set, and here's what I made over here. Br is going to be the green one. So it's already made. And yeah, that's why it takes time to do all these things, right? So here is the Br. Hydrogen is on the left-hand side. The red one is the Cl. By the way, if you ever forget this, you should always write on your card or on your notebook, which color is which atom. The black and the white is pretty clear, okay? Always carbon and hydrogen. The reds are supposed to be halogens, but we have two halogens here, so I'm putting the green one as bromine. Okay, so this is one. And then I made the other model as well. And in this case, again, remember the red one is going to be the chlorine, right? So chlorine is going at the back, hydrogen is here, bromine is this one, this is CH3, right? So this is the model for this one. So these are the two models that I have made without trying to figure out, okay, if they are the same or not. Because now once I have the models made, now I can keep them next to each other and see if they're mirror images, and look, they're not mirror images. So then I can try to go ahead and place them on top of each other, and they completely superimpose. So if they're superimposing on each other, it means they are identical molecules, they are the same. Okay, so this is one way of doing it, and this is a good way to get started. If you have model sets, then this is how you get started. Now the second thing to do, okay, if you're under time crunch and you're trying to figure out if two molecules are the same, is to not make models. You can make one model, okay? One model is not a bad thing at all, because that really helps you, okay, with what you want to do. So the best thing to do to figure out if two molecules are identical is to do the RNS configuration, okay? And that's why you need to be quick in how you do these things, and that's where practice comes in, right? So I can show you only so much, the rest you have to practice yourself. So let me show you just on a card how you do this, okay? And then you will do this with the model as well. So here is Br, here is Cl, CH3, and here is hydrogen. Hydrogen we know is lowest priority, so that's at the back, right? CH3 is here, Cl is here. Now you can assign priorities here. So Br is going to be A, and then B and C, right? So that's how our priorities go. So Br is the highest priority here, and H I'm not even marking because I know that's going to be the lowest priority, okay? So if I'm looking at my model, okay, which here is the model for this one. So here is the Br that I'm holding, the CH3 is at the back, right? That's what I'm doing. So what I want you to do is I want you to try and visualize this molecule looking from here, looking from this side, okay? So when you look from this side, you don't have to rotate the molecule or put the, you still have to put the lowest group at the back, but it's already at the back this way, right? So now you're looking at it this way. What I want to show you here, okay, because this is a common mistake, is when you have the CH3 going to the back, the most important thing for us to do is to make sure that when we do the RNS, we make sure we go from the right atom, okay? So this is your atom right here, the one that I'm holding, okay, since I only have two hands right now. Okay, here we go. So here we have, the CH3. So this is the CH3. This is at the back, okay, right now. A is down here. So the most important thing is to know that Cl is coming out at you, okay? So the tendency is to say, oh, I'll go from A, B, like this, okay? That I'll go from A to B to C, okay? And that is fine. But if you do this, you're doing S, right? So that is S. So what is going on here though? That's not what's happening. This is the A, this is B, and this is the CH3. This is at the back. So if you look at it in 3D, this is actually R. Okay, so the 3D orientation can be a little bit disorienting also. Okay, so you want to make sure you know, you do the R and S correctly. Okay, and that is something that you have to learn to visualize. So that's why I'm saying, if you look at it from here, from this side, then you will understand that the CH3 is at the back. If you just keep looking at the paper like this and say I'm going to go from A to B to C, then you're going to get it wrong. Okay, because that's not the right thing. The CL is actually coming out at you. So again, let me show you. The CL is actually coming out, okay, at you. This was the orientation. What was the orientation again? BR was down here. There we go. Okay. So the CL is actually coming out at you. So you looking on paper, you were going this way. But in reality, you should be going this way, and this way is the right way. Okay. So as I said, it's a good idea to go ahead and get a model set. Okay, so you start getting used to looking at these 3D orientations. All right, so now we've done this. Okay, so now let's look at the other one, which I'll just pick up the model here, although I know that they're both the same thing. So in the second one, the CL is at the back, the CH3 is on the right. So let me go ahead and do that. CH3. Okay, so here we go. All right, so here in the second one, okay, the CL is at the back, the CH3 is here, and BR is here, right? And the hydrogen is going down. So this is kind of nice in a way, because in this case, since the hydrogen is down, you have to look from the top. Okay, top down. So again, this is BR is A, this is B, and this is C, right? Those are our designated ABC, okay, or the atomic number. So here now ABC is a little bit easier to do, because all you have to do is go around like this. So it's easier to visualize from the top, okay, if you want to. So that's another thing you can do. Now the third thing you can do is, if you don't want to visualize things, okay, then you have to rotate the molecule. And sometimes I find that the rotating the molecule on paper is just a little bit harder to do. Okay, so for example, over here, if you look at this one, okay, and you want to rotate this, so that way you keep hydrogen at the back, which you can keep the hydrogen at the back, but then you have to remember the CH3 is going to come where chlorine is going to go where hydrogen is, and then hydrogen is going to the back. Okay, so if you can do that, then it's fine. Okay, so again, I'm going to do is show you once more, and then I'll write it out. Okay, so here, when you rotate the top part, okay, when you rotate the top part to get the hydrogen to the back, okay, hydrogen goes here, CH3 comes here, Cl goes over here. Okay, so now I'm going to write that out really quickly. So Br is here, Cl is here, CH3 is here, and hydrogen is at the back. Okay, so Cl comes here, H goes to the back, CH3 comes over here, right? So now you have the proper looking thing, right, where you keep the hydrogen at the back. Okay, so now you can go ahead and say, okay, I'm going to go from Br to Cl to CH3. So now you have the correct configuration, all right, with this. So you can do either of these three ways. Okay, make a model, that you can do. You can check how you're looking at things, whether you're looking at it from here, or the third thing is how you rotate the molecule. Okay, so rotation is not hard, you just have to get used to it. Okay, and again, practice is the key, okay, for everything.